All right, welcome. Today, we're going to dive into one of the biggest buzzwords in software development, microservices. Now, if you're in a systems analysis program, you've probably heard this term thrown around. It's a really core concept you'll need to get your head around for building modern, scalable apps. So let's break it all down, let's demystify it together, and we're going to start with a problem I bet a lot of you can imagine.
Okay, so picture this. You build an amazing application. I mean, it's a total hit. Users love it, everyone's signing up, the business is just exploding. This is the dream, right? But here's the catch. With all that success, you start running into some major headaches. The very code that made you successful is now, well, it's starting to slow you down. This is such a classic story in tech, and it's the perfect jumping off point for our conversation today. So before we can really get what's microbe about microservices, we first have to talk about what came before it, the monolith. You know, this is the traditional, old-school way of building software, and honestly, it's where most projects still start out. Yeah, most apps start with a pretty standard, logical setup called a three-tier architecture. You've got your front end, that's the user interface, what people actually see and click on. Then you have the back end, which is like the brains of the operation, holding all the business logic. And finally, you have the database, where all the data lives. So think of like an online store. The front end is the website you're browsing. The database has all the product info, customer counts, everything. And the back end, it's the thing that manages your shopping cart, processes your payment, all that good stuff. In a monolith, all of this, it's all one giant, tightly coupled system. And that all-in-one approach, that's what we call a monolithic architecture. A good way to think about it is like a single huge office building where every department, sales, marketing, engineering, is under one roof. And you know what? For a startup or a simple app, this makes total sense. It's way easier to develop, test, and launch when it's all just one single unit. Simple. But, and there's always a but, right? Here's the twist. When that business starts to take off, when the application gets more and more complex, that beautiful simplicity, it starts to become a massive problem. Suddenly, that single office building feels really, really crowded and nobody can get anything done. So you hire more developers, you keep adding new features, and pretty soon the complexity just goes through the roof. I mean, look at this list. But that fourth one, testing the entire application for a small change becomes a nightmare, that's a huge one. This is so real. Imagine your team just wants to change the color of a button on the website. A tiny, simple change. But because everything is tangled together in this monolith, you now have to retest the entire payment system, the shipping system, the user login, everything, just to make sure you didn't accidentally break something. Deployments turn into these slow, scary, super stressful events. And what happens when you get more users? You gotta scale, right? Well, you could do vertical scaling. That's just buying a bigger, beefier, more expensive server. But eventually, you're gonna hit a wall, both physically and financially. So you try horizontal scaling, where you just add more servers. But here's the big problem with the monolith. You have to copy the entire application onto every single new server. Even if only one tiny part of your app, say the user login service, is getting all the traffic, you still have to duplicate the whole thing. It is so inefficient. And all of this eventually leads to a state that developers have a very descriptive name for, the big ball of mud. It's a fantastic term, isn't it? It perfectly captures what happens when a codebase gets so tangled up, so interdependent that nobody, and I mean nobody, really understands how it all works anymore. This is the place where good ideas go to die and innovation just grinds to a halt. So, the big question is, how do you get out of this big ball of mud? Well, this is where the hero of our story makes its entrance, the microservices architecture. And it offers a totally different way of thinking about how to build software. Instead of building one giant application, the idea is you build a collection of small, separate, independent services that all communicate with each other. Each service has exactly one job, one business function it's responsible for. So you'd have one service just for user logins, another one just for processing payments, a separate one for the product catalog, and so on. This table really nails the key differences. See, with a monolith, everything is locked together. But with microservices, the magic word is independence. Let's say you need to update the payment service. Cool, you just deployed that one service. The user login service is getting slammed with traffic? No problem, just add more resources to that one service. And here's something really cool. Your payments team could decide to use one programming language, while the inventory team uses a completely different one because it's a better fit for what they're doing. That kind of freedom is a game changer. So, okay, what really makes all of this work? Well, it all comes down to a few core principles that give you this amazing flexibility and also make the whole system more resilient.
These are pretty much the pillars of the whole microservices idea. But I want to call out that last one, design for failure. This is a huge mental shift. Instead of building a system and hoping nothing ever breaks, you build it expecting that things will break. For example, let's go back to that online store. What if the service that generates product recommendations goes down? In a microservices world, who cares? The rest of the site, the search, the shopping cart, the checkout, it all keeps working just fine. The system is built to handle failure gracefully.
Okay, now this is a really important concept, how these services actually talk to each other. Older architectures often use what we call smart pipes. Think of it like a really complex, centralized post office that's in charge of routing, translating, and managing every single message. It's a huge bottleneck. Microservices flip that on its head. They use dumb pipes, just simple, standard ways of communicating, like a basic web API. All the smarts, all the logic, lives inside the services themselves. This keeps the communication simple and makes the whole system much more flexible. Now, I don't want to make it sound like this is a magic solution for everything, because it's not. Microservices are not a silver bullet. This approach comes with its own set of pretty serious challenges. Basically, you're trading one set of problems, the monolith problems, for a completely new set of problems.
All of a sudden, you're not managing one application, you're managing a complex, distributed system of many little applications. That's hard, and it means you absolutely have to invest in automation for pretty much everything. Deployment, testing, monitoring, you name it. But honestly, the biggest point here is the last one. Moving to microservices isn't just a tech decision, it's an organizational change. You have to shift to having small, independent teams that own their service completely. You know, the whole you build it, you run it philosophy. It changes the entire way your company works.
So we're left with the big question, monolith or microservices? And the truth is, there's no single right answer. It's all about trade-offs. The monolith is awesome for getting started quickly and keeping things simple. Microservices give you incredible scalability and flexibility, but they add a ton of complexity. For you as a student and a future developer, the most important skill you can learn isn't memorizing which one is better. It's about deeply understanding the pros and cons of each, so you can look at a project and make the smart choice, picking the right architecture for the job.